name is Joan. I'm a playback data engineer at Netflix, and we do use Scala, so I thought that would be interesting to show it at Java user group, since this is a mainly JVM-based language. And yeah, so how Scala ruined my Java, kind of like I was a Java developer, still is somewhat, and I kind of like picked up Scala and kind of like was like, oh yeah, that's pretty cool, and then I saw the features coming and so on. We'll come to that. So I'll start with a little bit of history. In 2001, there was actually a language that came out called Pizza. We have Pizza here. And I mean, although it was like named the language, it was actually a superset of Java 1.4, which just added generics, lambdas, and record or case classes. In Scala, we call them case classes, but they're record classes, I guess, in Java, and pattern matching. And that was like kind of like more like a POC for features that could be introduced into Java. And I think Java, so from what I heard, Java was like saying no thanks except for generics. So they were like, yeah, generics, we want that, just implement it. And lambdas, I think the reason was now they support inner classes, so that's fine. And the rest, like, not interested really. And then Java, like in 2004, Java 5 came out with generics. So that was like coming from the language Pizza, basically. And at the same time, in 2004, Scala came out with everything before and more. And then I couldn't put like the whole history, I would be crazy. But the interesting thing is that those features kind of trickled into Java, and they're now in the latest version of Java, at least since Java 14, where in Java 8 we got lambdas with the Stream API that's built on top. We got switch expression that can kind of pattern match in 12 in preview. And in 14, we got record classes, which are basically case classes in Scala. So the take from it is that Scala has kind of like influenced quite a bit of the Java land, and has always kind of been in the spirit, even it's been created for that. It's been kind of testing new things and going a bit more, into unknown lands, whereas Java has been more careful about features, and which is also a good thing. So I like to show this. This is actually a screenshot of a slide from the guy who invented the Scala at one of his talk, and he was showing just the grammar size. It's a controversial slide because this is like the grammar size of the languages, but it doesn't. Well, he was trying to see how that could be related to the complexity of a language, or at least learning a language. And we can see like Java, I mean, it's Java 8, maybe it's a little bit higher now with like record classes and all those stuff. But C#, which is like kind of a fork of Java, I guess, added quickly features, and now it's become like a huge language. So potentially complex to learn, but the features, as far as I understand, they are more focused on specific use cases, so you don't really have to learn them all together. But when you encounter them, you kind of like you have to like learn what they're doing. I don't know. For me, what was surprising was Kotlin is pretty new and was kind of like also a branch of Scala, kind of like we'll redo Scala, and it's already like almost double the size of the Scala language. And Python obviously is like very small because it almost has no type system. So yeah, interesting slide. So I didn't want to do something too boring, so I'll go straight into a demo. And just dive right in. I have some notes here for myself. So I'll just go to a terminal. Everyone can see? Let's make it a little bit bigger. So I'll just create a folder, and we'll I'll name it hello, and we can just create a project from there. And by the way, I have a video on YouTube where I did that in an Apple store. It just works. We have nothing installed. And then you would you would basically just like let's get Scala CLI. That okay? I don't have internet. Nice. I forgot about that, but let's hotspot quickly.
I think the Wi-Fi is on the board.
Yeah, I'll just.
It's quite a list to go find it.
I think it's just gonna connect to it. But I have it installed, but I wanted to show how you can. Which one is it? Charlie. Charlie. Do you see it?
It may just be called Office as well.
Yeah.
Which is
It's Office, and then there's the password.
Where is Office? Office here.
Mm-hmm.
Modern. 101. Yeah. Connecting. Yeah. All right. So just you can install Scala CLI like different ways, but one of the things that I'll do here is just not install it, but just download an executable and put it in the project. So basically, we have like just a Scala executable, and then we can create like a little main. So hello.scala, and inside we'll just put a main. So a main is an annotation main, and then a function. We're going to call it hello. So we create functions with def, and then the content of it, I'll just print line. So that's kind of hello, and that's just a main function which is just printing hello. So let's save it and let's run it. So Scala dot will just run the project, and it says hello. Okay, pretty simple. And something we can do is we can open the project. So I'll just open it in the IDE, and we have full IDE support. Oops. So yeah, we have full IDE support. You can jump to definition. Yeah, you can do everything basically from there. So let's modify it and let's add some args. So like a name. So type annotations are, this is a parameter to the function, and type annotations are after with a column, kind of like TypeScript, I guess. And I'll just do hello name, and we can try to run it. So I think I can open the terminal here. Scala dot and pass parameters. So hello jog. And yeah, we just have a parameter. So like we don't have to fiddle with like arrays of args and stuff like that. You can put multiple stuff here and have like them parsed next to each other. I think you can do probably you can do like name. No, it's not. It's like one after, it's sequential kind of. Yeah, we can package it. Packaging it is just package dot, which is dot is this folder again, and then you can just execute it. Yeah, I'm blocking it a little bit. So yeah, it's I need to give arguments. Sorry, drug whatever, and so that executable is just like a small kind of jar with I think it has a startup script in there. It's very small, I think. Do -h. I can if I can go in the other terminal so for you to see better maybe. -h the hello. Let's have a look. It's very small. It's like nothing because I think it has to download the dependencies. If there, I mean, there's no dependency, so it needs the JVM to run. So if we want no JVM, we can actually do package dot and native image. I need to do F because it's already existing. It needs to override the hello. So Caveat is one thing in the Apple Store. I tried to do that, and it wanted the developer tools to be installed on the laptop. So this one I was not able to do it in the Apple Store. The what do they call the Mac Genius or something in the store were like easy with the terminal. Same thing. I need to give arguments. Yeah, so you can see like it's super fast. Like you time it. It's a normal GraphVM image. It's not nothing super specific, but it's super easy to create. I think if you look at the size of this one, 12 megabytes. Yeah, so it embeds quite a bit of stuff, I guess. Yeah. Enough of packaging, I guess. Something we can do is just like, if you want, you can put those directives in comments, and it's going to be doing using JVM 22. You want to use JVM 20. I don't have it on my laptop. Let's try to run it. Let's just run it. Okay, I need to download it. And it would download. So the cool thing is that you just send. Sometimes I'm like at work, I have a snippet. I'm complaining about like, oh, some tool is not working correctly. So I just, again, I forgot the arguments. I complain about like some tool is not working or something, and I just send that snippet of code, and someone can just run it instantly like that. I set the version of Java. They have Java. They don't have Java. It just downloads the right thing for me. You can also set some dependencies using dep. I'm gonna use one quick thing from Li Aoi. Li Hao. Sorry, like this, and it's gonna be oslib. It's funny. There's I never saw that there was auto completion here. And now here I can probably do something like os. So this is probably going to be red. So let's re-import for the IDE to understand this, to download this library and have it in your reindex, stuff like that. You know? So os.list, for example, I can list the pwd, like the current directory, and I don't know. I'm going to do a for each print line. Let's run this. I guess I need to remove. I'm going to remove the arguments so that we don't have to deal with that. Just lists the current thing. You can probably package it as a native image as ls and replace ls with 12 megabytes ls. Yeah. I mean, you can read all this stuff, like, I don't know, the intro. I'm just going to put the intro in there. And put read, and that's going to be, I think, 00 the intro.md. Yes. Why is it red? I think it's IntelliJ being slow. I think, I don't know. We'll see. Readable path, yeah. pwd intro.md. I think I have it. Oh, I'm not printing anything. Sorry. Let's print it. Print. There you go. We're printing the weird way, but we're printing. Anyway, so you can like kind of like get the gist. It's just you can script things like pretty quickly. And also, there is something we can do is we can rename this, like, just call it not Scala, but .sc. And these are script files. Remove the hello world here. Okay, TJ needs to. Remove the hello world, just do this thing, okay? And this can be run, like the script can be run hello sc, and it runs the script. Another thing we can do is we can add a shebang. Let me cheat a little bit and go in the documentation, like shebang. Actually, no, I have it here. I have my notes here. Shebang here. There you go. Yeah, add a shebang here. So it's running the Scala thing, and now we should be. Oh, we need to do make it executable. So chmod plus x, and then we should be able to just run the script like this, Python style. So yeah, that's kind of it on the like getting started. It's like pretty quick. Coming back on the presentation, there is a few things that I want. I need. I don't want to go through like the syntax and everything, but there's just a few things that needs to be probably said about it. Is the declarations are unified, so there's no different syntax between declaring a function, declaring a variable, declaring a value. So it's kind of like this. You have a def x. It's a function. But I guess what changes is just the execution model of this x. So x is not going to be executed until you call it. But if you call it multiple times, you will get multiple times. It will be evaluated multiple times. A val is a value. It gets eagerly executed when it gets evaluated, but then it's not executed multiple times. A lazy val is not. It's just lazy. It's not eagerly executed. So like here, if I execute, we're on slide 04. You have evaluating y because y is eagerly executed. That's why, and that's why. And then if you x multiple times, it's going to be called evaluating y, and then xx. If you y, let's do y. It's just going to do nothing, just y one time. There's some warnings because those expressions are doing nothing. The compiler is like, you're doing nothing with it. Why do you have this code? And z, what do you think z is going to be doing? It's going to be y and z, even though you call it multiple times. So you have like, in kind of like easily, you can just do a singleton kind of. You don't have to do like the 10 lines that you would do on a singleton. Just have like this lazy val and that's it. Another thing is everything is expression. So everything is expression. Like this is Boolean, and again, yeah, I can add the type anywhere. So like I can add a type here and confirm that this is the right type that I was expecting. So like if I did string here, it complains. This is a int, and you're expecting a string. So those types, they don't just go on values. They can also go on functions. They go everywhere you want. And those are obviously expressions. It's the same in Java. And so what is println? Println is actually returning unit. Unit is like, you can think it as a void, but this is an actual type. And it's unit of computation, kind of like this is the idea. And so if else, in Java, you have if else's that are statements, and you have ternary operators, which are expressions. We don't have any difference between that. So that's why the syntax is kind of concise, because we just have if else, and they are expressions. So this is returning a string. Answer is a string. You can see here. Same. Okay, so if you return different in the two branches, you return different objects. What is going to choose is the lowest common a type basically. So it's runtime exception because both extends runtime at some point. If you have if but you don't have else, then it's a unit of computation. It's just void kind of. Semicolons are optional. You can put them if you like them. I don't think the compiler cares. I think it cares only if you put multiple expressions next to each other, or if you want to code everything on one line, I guess. Brackets are optional, like Python. So here is a block of code where it's a function that has no brackets, but you can have brackets if you want. That's also optional, which is highly debated. You can also have indentation based on no brackets, but have an end keyword. Often, like my take on this was like, oh, this is gonna be like so long to type. But actually, with the ID, you just do and it's like there usually. Oh, en enter, and it's there usually. Yeah, you can have blocks for val also. That's the thing, because it's unified. You can have a block and do like some stuff in there, and then return that into a val. And yes, the last statement of a block returns. You don't have to write return. Sorry, I forgot to mention that. So the last statement is returned automatically. And so I think brings us to I guess this is becoming like the motto of the language: safety and convenience. Pick two, because usually everything, systems, languages, everything has to pick either you're like kind of like Python, you can just like write quick scripts super easily. You don't have to care about the type system, nothing. Or in a large system, you want like kind of more like a type system, all the machinery, and verbosity is good because it's like it's, I mean, good depends, but like it's more intentional, more maintainable, and so on. And often it's seen like dynamic typing also versus statically typed. And Scala is kind of trying to aim with both of the world. So you haven't seen me writing too many types here, but there is a type system. And kind of like Java now has var, the keyword, with type inference, we have that kind of everywhere. You don't really have to put types, but it's tracked. The compiler will track everything. But it's recommended for public members of objects to put types. It's documentation. So it's like, it's recommended to put documentation. It's not forced. But yeah, something in terms of trade-off. I put like a few. There's so many examples. It's tuples. Tuples is I took an example from Java, like this. This map factory static method of, which gets key and value, key value. I was looking at it. I was actually surprised. I discovered it today. But I was looking at how it's implemented, and basically copied 10 times off. They copied it 10 times for like actually more than 10 times, 11 times, because no arguments, then 1, then 2, then 3, and so on, like this. And I was like, wow, okay. And in Scala, they have this, it's kind of like a same factory method, but we give tuples. So this is a tuple, the bracket. So key value. And then if you look at the implementation, it gets elements of tuples, key value, and the star is our way of saying var arg. That's it. I mean, it's a one-liner, really. The function is this, including the implementation. But the implementation is forwarded somewhere else. So tuples is nice. It's like, for quick scripting. But you'll tell me, yeah, but like, points, for example, we have a list of points. It's X and Y. You can have a list of tuples of double and double. Now it's a new thing that is actually not released yet. We can name tuples, so we can give names here, X and Y, and then you can call them on the tuple. Whereas before, it's more like a list. You get first element or second element. But if you try it in a tuple of 2 elements, if you try to get the third element, it's gonna blow up at compile time. So it will tell you, no, it's not good. And then you can also, at your convenience, go like into like lose maybe some convenience, or if it's used, factoring out, create an actual class point. So a case class is like a record class, really. and have it, normal class, like nothing different here. So basically, what I'm trying to show here is that you can go convenient, but not very, like still very typed. The safety is still there, but maybe less documented to an actual class point. Another example of tuples is here, where let's say we have a function to.json. So we're writing JSON, and we can give, usually we give an object, but we can give a tuple here, which has 3 fields, name, employer, role. And name is another tuple with last name, first name. And you can write that. That's going to be, each tuple is going to be translated to an object, I guess. And then let's say we have another function that reads JSON from that row JSON. And these square brackets are like type argument. It's like the diamond syntax in Java. But we have it, I think they went with square bracket because they want you to feel like it's arguments, parameters to the function. They're just types. They're not value, value parameters. And so here we're giving a type which is like a tuple with a field name and just another tuple with one field first, and it's type. That field is type a string. So then you can you have a full ID support. I'm doing trim on it, so you get you deserialize just what you want. So if you had to go through a class, you had to define your class and then serialize those things, and then deserialize. If you just want to deserialize just one field, then you have to create another class and then use that class. So kind of like here, you can just straight do the thing in line. So that's pretty cool. Union and singleton types and enum. So we have 2 features. One is union type and one is singleton type. And I wanted to show you how I actually, well, we just spoke about Boat Club. This is my script for booking boats automatically. I just extracted it. Didn't implement anything. But I have this list available boats, and it gets the location, the date that I want, and the time, and optionally the type of boat that I want. I didn't want to go through defining an enum and then use the enum, and then now that I'm using an enum, I need to probably set what's the actual name, because you cannot have space. It's going to be North Miami without space. Now I need to care about serialization and so on. So I just have a union of singleton string. So at runtime, obviously location is going to be a string, but here the type system locks it to only those 4 values. So that's a cool thing. Same here. It's inside an option. Option is optional. It's the same thing, really. Or go with an enum, and I don't know. I copied this example of how we set enums. Good. So yeah, why safety? I guess. Why are we looking for safety, but we don't want to compromise convenience? Because so far I showed you a lot of convenience, but why do we want safety? Well, there's this this one is from where is it? The national some standard, I don't remember, but basically the cost of a defect. When you realize that you have a defect at the requirement, this is okay. It's relative to a requirement. Yeah, I think so. Yeah, this NIST. Yeah. So yeah, if you spot a defect in design and architecture, you already it costed you 3 times that if you code it at requirements. And coding. So design, we cannot do much. Language is not even in play at this point. Coding, that's the thing. Between coding and testing, if you code something and you realize that there is a mistake at testing, it already costed you twice more than if you code it at coding. And worse, if it goes through your tests, because you're going to have to write all the tests, and it's impossible to cover the whole world. If it goes through at deployment and then maintenance, it's exponentially worse. So we want to catch it as much as possible during while you code, basically in your IDE. That's another one from IBM actually, but it's the same thing. It's exponential basically. So I want to demo some other kind of like dependency injection, for example, and some other things. So dependency injection, I implemented a quick demo here in plain Java. You'll probably laugh at it, but here's a main. It calls. Ignore the red for now because this is like a sub project. It's not loaded. Yeah. So main that calls send message ping to a message service. Message service is just as this send message, which is a static function. It would do some API calls, and for now I'm just printing. And so the problem of that is we cannot, like, it's untestable. You cannot test send message without doing the actual API calls. So I can run it. This is the thing here. Let's run it. Yes, message ping send. Okay, but it's not untestable. So another way we can do it is, again, it's still plain Java, but we define an interface client, and I guess it's a HTTP client, so it's doing a post. There's a default implementation, which is this one. We're doing the API calls, whatever here. For now, we're printing. And then in the main, I guess we are creating the default client and passing it to send message, and send message is like getting a client, using the client to do the API calls. So now we can kind of test it by mocking or having an implementation of different implementation of client. And in your test, you call the send message with the different implementation of client. I guess we could have had it, defined as a member here and have a different constructor and so on. But problem is that it's very verbose. I guess passing parameters like this is very verbose. Same thing, we can try implementation. Yeah, it prints whatever. So I guess people came up with Spring. So let's have a look. Same client interface. A default implementation that we tag component. I'm not proficient in Spring, so I'm trying my best here. And then message service is also a component, but the difference is that the client is auto-wired, and this thing gets wired automatically. And in the main, I guess we have to do some Spring Boot stuff. And Spring, there's more logs because Spring boots and so on. It takes 0.3 seconds to start just to print one message. And so the problem of that is, if we come back to our slides, problem of that is that it's runtime wiring. So the cost of a defect would be at runtime in your test at best, or during maintenance when you deploy the app. We have apps that run only in kind of like production environment, not on my laptop, because it has to have access to stuff and so on. And running through the whole deployment and so on, it's a nightmare. So how can we do better? Let's have a look. Yeah, so where am I? Yeah, Spring error. I put this meme. But you can actually try it. Like you can like the default client. I just comment this out, and I put the oops, not this one. This here. Run it again. And yeah, failed to wire the bean, whatever. So yeah. Jumping to what solution Scott comes up with. So the thread is basically like an interface. It's the same thing. Don't bother with the differences. And here's an implementation. I did everything in like indentation base. You can put brackets if you want. But here's the default implementation. Same thing as in Java. But what's interesting is that the send message takes a second parameter of a second group of parameter, which takes the client, and there's a little keyword using, which means it's like auto-wire, but on a function. So this will get wired automatically based on the type. And the implementation is just using doing the post, usual thing. And in the main, basically we have another keyword, corresponding one, which is called given, and it's only the type here. And we have a default implementation, and we call send message, and we don't have to give the pass the client in parameter. And so this just works. But the funny thing is that if I forgot to have a client here, I have an error here. Oops. I have it's red here, and it says no given instance for type client was found for parameter client and method message, whatever. So that's kind of like at compile time in your IDE straight away. And I implemented a little test here where I implement a client inline here, and this is incrementing cold. I send message. I said that cold is 1. Pretty simple. And same thing. Also, something that is cool is that maybe you know X-ray in IntelliJ. When you command and tap a second time and hold command, it gives you like types and stuff. But you also see what's wired. So you can see like given client is wired, and you can command click on it and jump. If you give it a name also here, because you can also use it as a value. When you jump on it, when you select it, you see it highlights everywhere it's being used. Here it's a 2-line code base. So yeah, it's not super big. So that's kind of like how we do dependency injection. Moving on to null safety. I found this one funny because optional, but then you can set null, and then messes up everything. So in Scala, it's behind a flag. For now, I think it's being tested, so still now. But if you have that flag on, we just cannot assign null to a string, for example, or int or whatever. I mean int, yes, but like any object. And so for that, you would have to. So the compiler says actually, so null for us as a type. Null is of type null with uppercase n. And it just does not fit. The null does not fit into a string, so it just does not work. For that, we actually have to do a union. We need to use the union feature, where the type is like string or null, and then you allow nulls in this thing. Here, I'm putting a string with like trailing space. And the interesting thing is that I cannot call trim on it. I actually have to. We have the kind of like switch. We have a match statement, and you need to match on this thing as a string, and then you can do a trim on it. Or if it's a null, you need to handle that. Maybe just forward the null, and then yeah. Why the case? I think IntelliJ is just being slow here.
Uppercase null?
Say again?
Uppercase null?
No, it should be just the value null. I don't know why. I think it's just IntelliJ being slow. No, that should be it. Yeah, G formatter is like this. Yeah, that's a feature. That's pretty cool. Also, unrelated to null safety, but this thing does not work. For example, we also have like equality safety inequality basically in the types. It actually checks that is never possible. Concurrency. So we have virtual threads in 2021. They've actually been thread pinning has been fixed in 24. So let's have a look at how this works. I put a little Java example. So we have 2 functions, get username. I just put like, I put a first print line and then a sleep to see how the function takes time to execute. And another one here, so get username and get the balance. And let's say those are API calls, and you have a main function where you create, this is all red because it's still a preview. Yeah, so here we need to create a structured task scope, and then we have the scope, and then we can fork and call the functions. And then something we need to not forget is call join. If you don't call join and you call get, it blows up at runtime. And I was trying to understand, why did they do this API? Like, why can they not do some safety here where you just don't make it impossible. Like if it's gonna fail, just make it impossible at compile time straight away. I'm not sure why, but here is the same one, and it's using virtual thread. So that's another example where Scala is getting features from Java too, like the Project Loom, virtual thread, and so on. This thing is only possible on Java 21 up. So yeah, I put a main here, and oh, this is the two same functions, you know, get user, get balance, and we have this parallel. You run both of them, and it gives you a tuple. And this is an example where we're deconstructing the tuple in place, and we get the result of both. So that's like two-liner. There are cases, and you can do like stuff like you can do a timeout here, timeout, and you can have like 1 minute, whatever here. 1 minute. I need to import some stuff, I think, for the minute. But yeah, you can do timeout. You can do race. Race, you give 2, and they race a lot of things. But if it's not enough, we have this kind of more Java. I guess the same kind of like Java. You fork stuff here, and you join. We don't have to call join. Just like it's the join is the get kind of. And the way it works is that if you look at the signature of fork, it gets, again, there is a using here of aux, whatever the object is. So it's some context that we are in within a supervised block. And if you look at the the supervised function, it gets this question mark arrow kind of. It's giving you aux as a kind of like given before. Like it makes it available within the brackets here, within the scope. And this fork is catching it. But if you call fork outside, it's just not going to work. It's going to tell you well, it's a top level definition, but if I put it let's put def over here. Yeah, it says like I cannot find yeah, okay, this operation must be run within a supervised and so on. So we have like compile time safety. That's the thing. That's concurrency and string templates. I know it's a bummer. It was removed in the preview was removed. So I'll show you the preview in Scala. So string interpolation. I wrote some libraries that are using the string interpolation. We call it string interpolation instead of templates. Simple string. I think I just showed you before. Same thing. But we have a Comcast who did the library. So there's a import, and then you can do like some IPv4, whatever. This would be like how you would do probably in Java. But you can have a string interpolation IP, for example, here. So you can also have IPv4 IP here. But if you do a mistake here, it does not compile. It's just does not compile. IPv6, I think they have yeah, some stuff here. So if I put a valid IPv4, it does not work. Valid IPv6, that's the only one I know, works. And that gives you IPv6 object or IPv4 or IP. So that's pretty cool. We have another one. This is Scala CSS. So it's like CSS in Scala, kind of crazy, where they have a string interpolator C as color. And yeah, and like I can trick it with an R here. And yeah, it says hexagon notation must be whatever. But this is not language. It's an implementation of the library. It's using the compiler, but it leverages the compiler. But yeah, it still does. It's still a library. It's not the language magicness. RGB. I think there was a 1, 255, 100, whatever, 50. That works. 56 doesn't work. Invalid value. It even tells you like its red value is not. Yeah. Same with JSON. We have like JSON. If you have the JSON, it's useful for the test. To be honest, we don't really use it in outside of the test. But when you have when you run your test, you just want to have a same thing. Invalid JSON is not compiling. And last one, SQL, same thing, but like SQL. So we have a whole SQL library called Skunk that, yeah, compile time check your queries. And if you want to go further, we actually have something called refined types. It's a library also, but ID, you can have a string. You can set with this. They named it that way, that type, but minimum length 3, maximum 32. You can set it on the user fetch ID, whatever, and this is good. John, it's empty, does not work. Look at the error message. Could not safely. Oh yeah, message should be minimum 3, maximum 32, and if you put 3, that should be good. And if you put 32, it's not good. So yeah, numeric, I'm gonna shut this down. Yeah, so alphanumeric. We have many. We have even like regex, so you can have an email regex validation with you can customize the error message when it's gonna get it. And there's integration with like database, like the SQL thing that I showed you. You can have integration in that so that it rejects straight away the message, so it's safe within your application. We also have integration of that library with HTTP libraries, so rejects anything that comes in. Front end. So Java is not the only platform that Scala targets. We can compile Scala to JavaScript. I know it's crazy. And as of yesterday, I mean, it's not as of yesterday. They already had a preview where we can compile to WebAssembly. But Firefox and Safari now supports fully all the features that Scala needs for running in WebAssembly. Except Chrome. Chrome is behind the flag. It's still in test. But there's just for error exception handling. You need to enable a flag to use it. It's not very practical to ask all your users of your website to enable a flag to go on your website. So.
Any word on Edge?
I have no idea. I don't know. I don't know. Yeah, that's a good question. So I put a little project here. Let's have a look. I'll just run it first. Let's run it here. And this is going to be Scala-JS. Actually, let me switch there in this folder, and I'll put. I have a little README in there, I think. Let's see. Yeah, little README. npm install. I think I've done it. Let's do it just in case. This is front end, so we're with npm and stuff, you know. Okay, 0 vulnerability. So we can launch the compiler that is going to package the -w is gonna watch any change of the file and output this into a JS. I'm gonna -f to force override it. And then in the second terminal, I'll just launch. Well, you can run it in Node, okay? But I'll just launch the dev environment, okay? The such file. Oh, I'm not in the right directory. Sorry. cd Scala.js. All right, we have a little local thing here. Very high quality front-end development. And let's have a look at the code while this is running. Code is here. I name everything hello for some reason. And yeah, so this is like, I don't know if you're familiar with React. This is not React, but this is, you can also do React. So we're declaring a variable here, and then a var object, I don't know, and then we're defining some like, should be familiar, divs, label, input, on mount, focus the mouse on it. This is the placeholder, and then whenever you type on input in here, there's this thing that says put put whatever you input into the name var. By the way, that's a function name, def -- greater than. And then we have another div, sorry, where we're saying hello, and the text, the child, so the child is like, in HTML is what's inside. We listen on the signal. We also do a little, by the way, map to uppercase, and then we load this whole app into the element app. So the HTML is here. This is the ID app that I was saying about, and this is the main JS, and then we package the whole thing, and it's that uppercase. It works live, and I see a mistake wherever in that's the JS, by the way, generated. Name e just refreshes on its own, so it's like JavaScript development, really. Yeah, that's front end. And that's it, really. That's it. The source code of my slides is here. Yeah.
Cool. Yeah, pretty nice. Thank you.
And if you have